Start small, work your way up. And it's super helpful to follow someone else's path unless you have the expertise there on your staff or your group that can work through the issues.
Oh, you mean better to use the Lelo instead?
No, I mean, if somebody else has a project where they have the parts listed that you can use and plug in that work, that's sometimes easier than starting from scratch and trying to design your own system. After you build a few robots, then, you know, you'll make your own changes and feel comfortable.
Yes, that's true. So right now we are kind of work on piece by piece, like hardware first and then software. We don't know what's in front of us. Maybe some big problem there. So it's not compatible or need to develop some our own driver. So we don't know yet. Yeah, that's true. Yeah, but we don't have a kind of established hardware configuration yet, right? Do we?
It just depends on what you're building, what your tolerances are. There's a lot of factors.
Mm-hmm.
But we've posted it a few times, but there's just like the little teeny robot that you can get. There's a tutorial out there on how to put them together. If you go through and just build a few of these robots, spend $100, buy the robot kit. The joystick can be used on your next robot, and you'll learn a ton. And that it will be an easier path, I think.
Yeah. Yeah, I will word the kits. You have a link? I will probably word it like this week sometime, so that I think, yeah, like you said, have a hardware on hand may be helpful.
Yep. It's a little teeny small kit, but if you know what's going on behind it, you're learning a lot.
Yes.
And then either go through the tutorials on the ROS website or go through a class. That's another thing that's really tricky. If you try to start using ROS, it's pretty complex, and if you haven't gone through any tutorials, you'll just be stumbling around with little things that a tutorial would show you how to do.
Mm-hmm. Sure. How's the robot, like our robot going, the tractor robot, that testing well?
How's it going? Al's been leading up the lawn tractor project.
How is it going for me? I will, let's see. I would say we've got digital control of steering, digital control of transmission, GPS. Now we're doing integration testing of all of that. I had my electronics mounted on a temporary board, and I'm in the process of getting that refined and put into a Pelican case and remounted on the tractor, so I can get back in the yard and do testing. This week was about just reconfiguring my e-stop and putting the button that came from Jeff uses MPJA, is that the name of the outfit? So one of their buttons in a 3D printed case with a ground wire and a wire going to the magneto. So I've got to get that remounted. So progress, but trying to get the electronics more permanently mounted, so we can do more serious testing. And we have, I mean, Matt's got some documentation out in GitHub. There's some documentation in the Google Drive as well that, you know, was put there specifically for people trying to get started, just to break it down into steps and make it less overwhelming. Because I think for my lawn tractor, I've got 23 steps laid out, and it just feels like a lot, but if you take it one by one, it really fits together nicely.
Hey, Al, let's see that. Hey, can you hear me okay?
You're really muffled.
Oh.
Try again. We'll work it
Is
out.
that better?
Marginally.
Not much. Okay. Hey, I was wondering, do you have the software out in GitHub for the lawn tractor that you're going to use? The software you're going to use?
Yeah, so that's a, yes, sort of.
Okay.
There's a couple of places to look for software. So Matt's GitHub site is probably the first place, and then I have also been putting, I'll try to pull it up while we're talking. I mean, for me, there's quite a bit of software that you use for testing and whatnot, and so I'm just going to post this link. So there's multiple components that need software, right? I have been using, and Matt as well, an RPi, also integrated with a Teensy. And so there's software on the RPi, there's software on the Teensy. The URL that I just posted probably is more Teensy related stuff. So for me, I have a Teensy taking angle sensor, a Teensy driving the transmission servo, and a Teensy driving the motor controller for the steering. So each one of those has firmware on it. And then for the Raspberry Pi, it's primarily the Ubiquiti Robotics distribution for their robot. It's fantastic. You know, it's really inclusive and simple to burn and put on the Raspberry Pi. So if I were just starting out, you know, I would just try to trying to share again. In Ross Lawn Tractor, Matt's got other documentation as well. And so I would probably mix and match these, but you know, some time ago we put together the first few steps around just getting started, and you know, the only thing you really have to have is a laptop and an RPi, and you can do a lot of testing and understanding with just very little, you know, hardware. But you get ROS running on your laptop, you get ROS running on the RPi, and you can, with a joystick, run the simulator and move around and sort of see how things work. And then you can go into things like connecting a Teensy and doing, commands either in or out of the Teensy before you ever buy anything or need to fabricate anything. So you really can start slow. I'll stop blathering on and see what Matt wants to add.
It's awesome. Did you have a specific question, Alan, or just were wondering, like the ROS high-level software or the low-level controller software?
Yeah, I was thinking about the ROS software. If that's if you have all the nodes and topics and all that stuff is defined, the launch files, is that all stored in GitHub somewhere we could review it?
Yeah, you're familiar with the simulator,
Right.
and you're familiar with how the simulator works with ROS and how your robot works with ROS.
Roughly, yeah. I've looked through it a little bit.
Just on a very high level, your robot is listening for command velocity, and it's going to send back your localization or your odometry. So all of the ROS software is out on GitHub. It's in the simulator, and basically, if you use a simulator, the simulator is listening for the command velocity message from MoveBase, and then it's reporting back its odometry.
And that's the same thing, Al, that you're talking about you installed on your TC. And
It's different.
oh,
The
that's
TC is a low-level microcontroller.
okay, so that's separate software. Gotcha.
Yeah, think of the Teensy as the interface between, your physical hardware and ROS running on the RPi. Matt's got a diagram. I don't know if you can put your hands on it quickly, Matt, where you were showing the nodes, the various ROS nodes.
It's in the simulator, and you can open up RQT in the simulator and then look at each of the nodes. You can introspect. Are you familiar how to do that?
I think he was talking about your block diagram that you wrote up. So you just had a diagram you made with some kind of a graphics program, is what he's referring to.
That's what I was referring to, yeah.
Okay. I'd have to track that down. I'm not sure where that is. But all of the software is just sitting in the simulator.
Got it. Okay. And then you mentioned introspection. Can you talk a little bit more about that? Is that something? Yeah. Okay.
So you've been taking the class on EDX.
Right. Uh-huh.
So you're familiar with how to do like TF view.
Oh, sure. Uh-huh.
And then there is also, so are you familiar with RQT?
RQT?
Yep.
Is that where you see the diagram of all the nodes and topics and how they interact with each other?
Yeah, is that what you're interested in?
Is that the same as introspection then?
Yes.
Oh, okay, gotcha. Okay,
In
sure.
RQT, if you go under visualization, you can see the nodes.
Got it. Okay, sure. Then I had one other question. So in the class, we're in the last chapter now, or last session, and they're using FlexB for state machines. Is that the best tool to use for that type of activity, or are there other tools? Maybe a different way to ask it, is that the only tool that does that type of activity? You know, capturing the different, you go from state to state to state. Or are there other tools that do that same type of thing in the ROS world?
Well, a good thing about ROS is that it's probably done a new number of ways, right?
Yeah. But, and part of the reason I'm asking that is, you know, just getting started into it. You know, the class is using ROS, but there's lots of discussion about ROS 2. And then there's, you know, we use Gazebo a lot, but there's lots of discussion around Ignition Gazebo. I think that's right. Ignition is the newer version.
Yeah.
And so before I get too deep into these tools, you know, it's kind of like the old Python 2.7 versus Python 3.5 or 3.6. Well, since I'm just starting in, I'd rather start at the future state place rather than start old and then have to migrate a year from now. So that's where I was just wondering how to think about that, if I should be going straight to Ignition Gazebo. Should I be learning FlexB, or should I be learning something else? And should I be starting with ROS 2 instead of ROS?
Yeah, those are, I don't know. Anybody have any opinions on those?
Yeah.
I think it depends on your learning style. I can tell you, if you're a book, you know, if you like books, there's you can find a number of PDFs, ebooks, if you will, for ROS. The guy Joseph Lintel, for me, sort of explained how Arduinos fit with ROS and how you get them all to talk to each other. That was very helpful for me. Going through the steps, just getting it installed and using the simulator with the joystick, to me, is a fantastic way to sort of get your head around, you know, the basic components. I did find the link, well, a link to the block diagram of the physical stuff and how it fits together. I just put in the chat. Again, that Matt prepared that, and there's probably a better place for it, but that's one link to get to it. If I were just starting out today, I would go to step 1 through 5 in the Google Drive. And then I'd buy a motor controller and the steering motor and a Teensy and try to get it to work. But that's just one path. There's dozens
Yeah.
others, I guess.
Yeah.
Bowl of spaghetti.
Yeah.
And just be ready to be on a learning curve, because you're going to learn electrical engineering, mechanical engineering, software engineering. But it's all good fun.
Very good. Well, thanks for the input.
Yeah, that's excellent. Actually, Ellen talk about that. So I was thinking about before, like to modify a RC car, you know, with some of the Raspberry Pi to make it work. But I don't know. That's a good way, like the minimum hardware, like you mentioned, TNZ or motor control. So the RC car, is that a good start point or?
For me personally, I think it's an excellent starting point.
John Lee, did you see the post to the kit, the robot kit at the very top of the chat? All right. It's a big bowl of spaghetti. Just grab a noodle and see where it leads.
Yeah.
Not speaking of spaghetti, but Matt, what Bluetooth joystick did you end up getting to work?
This one I posted, I can post a link to it. It has a dongle, wireless controller.
So so you just plug it into one of the available ports on your Raspberry Pi and it's talking 2.4 or something?
Exactly. So that's the joystick. And it comes with that little kit. I mean, it doesn't come with a kit, but you order it. And then, so this is the tutorial on your first robot. And it goes through and gets your robot driving around with a joystick through ROS. So you use the Raspberry Pi, have two little motors. You have an ultrasonic sensor to detect if you're going to bump into something. And then you have the, you can drive it around. So there's a lot of things going on. If you can get this little kit driving around with a joystick, you'll feel a lot better. And then you can use your joystick. I mean, it's $25 for the kit. The Raspberry Pi, you're going to reuse. And then this wireless controller, you'll reuse. But you can buy all of these parts for $100 and get a robot driving around your kitchen table or the floor using a joystick in ROS.
And so instead of just a plain Jane radio control car, that kit looks more appealing to me than just using a radio control car and trying to hack it to use ROS.
Mm-hmm.
Although we've all done it.
Yes.
That's
Maybe more than once.
It's a natural progression.
Because then you want to put a GPS on it, and then you want something big enough that'll hold a GPS, and then you'll realize GPS is only so accurate, and you'll say, how do I solve that? And we'll be here to help you. Well, Jeff will. He knows all about that stuff.
Jeff, do you have any pointers?
Not right offhand.
Alan, what do you think is a good way to learn ROS since you're new on this game? Are you still thinking about using some hybrid?
I don't know yet. Definitely go through a class, and so I probably want to find another class to go through after I get done with this one, because that's definitely worth the time, and the cost is pretty minimal. So it's $50 or something, and so that was well worth it.
Have you checked out the classes on the Construct?
No, not yet. I've been just getting through this one has been enough up to this point. So, but I think it wraps up next week,
Yep.
or the week after, something like that. Next 2 weeks we're done, and so then I need to find something after that. And I think the piece that, I guess thinking about the design a little bit, like you guys just mentioned, if you've got the Teensy running your motors, see, I have that piece already working in Java, so I have that whole layer of interacting with my motors, and I pull out the positions of all the motors, which would be very similar to an ODOM reading. And I'm tracking that already, and I'm tracking torque as well. So I guess I could use and I guess I have my GUI for interacting with my robot or my rover built already. So I could keep the GUI, and I could keep the piece that interacts with the motors, and then I could figure out how to add ROS on, add ROS onto the side, or kind of the brains of the bunch would be ROS. All the planning, path planning, and simulation, and the visualization of what's going on in the environment, I think would be much better to bring into something like the Zero. But it's tough, and it's probably going to be a little tough to integrate that together too. So I've kind of started to think about it, but I don't know that I have an answer on that yet. I think my first step after I get done with the class, my first step is going to be, I'm just going to install ROS on my Ubuntu laptop and start building something pretty basic just to get it started, and see if I can do something on my own outside of the structured environment of the class. Just start playing around a little bit, get a little more familiar with it, with ROS core and launch files and a few things like that. And then I think maybe building the URDF piece, I think should be pretty straightforward. I'll use Blender to build it, and then I'll export it. And I already did that with just a block to see that I can do it. So I think I'll build a model of my robot or my rover and put that into an environment in Gazebo and ArcGiz, so I can see it and play it with it that way before I start trying to hook it up to the physical device. So that's a month's worth of activity, I think.
Yep.
Then I'll know a whole bunch more, and then decide where I want to go from there.
Then you'll have ROS installed on your laptop.
Correct.
That's about a month's worth of work.
Oh no.
Lino Robots ROSMe. You'll be set up in 20 minutes.
Say that again.
Lino Robots has a packaged set of commands. I mean, Matt has got a Docker thing as well that's probably equally smooth, but they've got it down to one statement: ROSMe, ROSME, and it loads wonderfully. Spoken by a guy who's rebuilt his laptop, I don't know, half a dozen times in the last 6 months.
Oh no. So I was listening to the Ignition Gazebo podcast. I think it was from the Construct, and they were talking about Ignition Gazebo. And this is just pretty current. I think it was from January, and they're talking about the next version of Ignition Gazebo would be aligned with the next version of Ubuntu, so 20 dot something, so that if you wanted to install Ignition Gazebo, it would already be part of the Ubuntu libraries, and you could just install it. Is anybody talking, I don't know if you know, on ROS 2, are they talking about making that easy so that it's just lined up with Ubuntu and you can just install it from the software center within Ubuntu?
It's a good question.
That'd be a Matt question. I haven't heard anything.
I don't know. Jeff, have you heard?
We need, is it
Well-
Jeremy that's on that team? We'll have to ask him when he's on.
Well, eventually things just catch up. So if they've got something new, as the new versions come out, just all of a sudden you can download that and you can just go out and say ROS install or say apt-get install, and it will actually install it. And if you're running the x86 version, you've got a much better chance of it working than if you're trying to run the ARM version. But it's just a matter of eventually you load a version and the stuff is just there. So it's just kind of waiting for it to show up, I guess.
Yep. Alan, have you taken a look at some of the other simulators that work with ROS, like Weebots and VREP?
No, I haven't. Are they pros and cons?
Always, right?
Yeah,
Always.
right. What comes to your mind as being some of the key pros and cons of either of those versus Gazebo?
That's a good question. I haven't used VREP or Weebots. I've installed Weebots and went through a couple demos, but I haven't used it. Haven't built a world or tried to do any modification in there. The Weebots have a pretty nice orchard world with a couple tractors moving around in there, and the tractors have like 3-point attachment. You can move up and down, hitch up and down, and things. But it's not a publicly released scenario or world, so we can't use it. Then I think if you go to ROSCON 2019, there's a couple videos on that Ignition. And some of that looks really cool. They're using a game engine, so more game-like. Looked pretty neat.
Yeah, it sounded very good.
One of the things that's nice about that, like I was saying, that Ubiquity Robotics Raspberry Pi image has a lot of things already built in, and I take a lot of things for granted on that that image. For example, like the startup script that automatically boots up ROS when you start the Raspberry Pi. You don't have to think about it, and everything's all running, and it all just works. And I've been trying to get that same setup working on the Jetson Nano for the last week, and I haven't been able to get it to go. It's amazing. I can call the ROS script. It's basically just a little bash file that has a ROS launch, but it throws an error and it won't start ROS on boot. So I switched over to hardware. I've been working on hardware, and then I'll do some electronics and then try to get back to software. We do have a new Ross Agriculture category out on Ross Discourse. So if you want to post things out there, progress or things are going. Yet another place.
I mean, do you have a vision for that, Matt, in the sense of what you would, I mean, do you have a preference or you have a suggestion? What goes in Slack, what goes in Discourse?
I'm open. It seems like Slack is more chatter, and then out on Discourse, it's more announcements or those types of things. So meeting announcements or minutes. Let other people know in the Ross community what's going on. And then one thought is to look for collaborators in other groups throughout Ross. So we may start a conversation in Slack, but that same conversation or same problem was solved in another group. And so having some visibility may be helpful.
Matt,
That,
yeah, the Ross course, is that more communication with the Europe group? I see the post from the snack. Is that true?
What was the question again?
So is that a Ross course is proposed by some people from the Europe group? Is that
Yes.
more for them, or is more worldwide for including us?
Everyone worldwide, but definitely,
Oh.
yeah. The Ross Agriculture Europe group is pretty big, and they've got some funding, and they're hopefully make some good contributions, and it's really neat to see them go. Exciting.
Cool.
Matt, I was looking at that Raspberry Pi gamepad. They're sold out. I came across another one. It just says 2.4 gigahertz and it's got a dongle. I'm wondering if it's the same same fundamental. Would it work, basically? I've never bought anything from these guys. And couldn't find it on AliExpress, which just surprises me. I didn't think there was anything that you couldn't find on AliExpress.
Looks really nice for $7, Al.
Was there any particular setup that was, you think, unique to the piehut.com guys?
I don't know. It just has a dongle and you plug it in and it works. I bought another Bluetooth joystick and I never got it working with the Raspberry Pi. But that one looks like it has a dongle and $7.
Hard to go wrong.
Yeah, yep. I'm still keeping the Lawn Tractor as the master. So when it boots up, that game controller is ready to go. So you can just start the lawn, turn power on the Lawn Tractor and then drive it around, start it, do whatever. It's not as robust as Jeff's setup. Jeff doesn't have to boot a computer to get his robot to move. That's the professional version.
We aspire to get there that someday.
The biggest problem you might run into using different game pads is that the buttons will be mapped differently, but you just have to go through and go through and push each button each time. and then go into that parameter file and say, I want this button to do whatever you want it to do. The first problem, of course, is if you plug it in and it won't talk to it, then you've got a problem. But if you get it to talk to Linux and show up, then it's just a matter of figuring out which buttons go where to make the thing work.
And they advertise Android connectivity. I'm hoping it would be. It would just show up as another port.
So hopefully here next week, Al, are you able to get outside and test odometry?
No, not as we sit here. I've got to mount my Pelican case somehow with bungee cord duct tape or something. So maybe this weekend.
Yeah. I got to start playing around with odometry again. So if you're out playing around, we can try to see if that works or how stable we can get that.
Yeah, it was, I mean, so it was, I have a, I can get the speed sensor on the wheel, the rear wheels, but I just haven't had it back out testing since I disassembled the electronics and bought a better bolt to connect the steering motor to the steering shaft. Because remember, I sheared the last bolt and it hasn't moved since.
I'm getting GPS hops. That's why I'll show you. This is a data set from I guess it was Saturday, but so I'm starting it and then turning in, going down a row, and then this is the data that's coming back. And I don't have RTK in the trees. I can get RTK float, but not fix. But as I'm driving out, so I don't exactly know where the tree line is here, but as I'm coming out of the trees, my GPS is reporting my position here. And then when I lock into RTK, it drops me here and then I come out here. So I'm working on trying to get the camera set up and get the GPS mounted so I can start running through and collect better data and try to see if I can avoid, obviously, that jump in position.
And that's with the F9P with a base and a rover.
Yep, the survey grade antenna. And it's pretty, I don't have the numbers on there, but it looks like it could be a meter jump there or just under.
Well, that's got to be frustrating.
That's odometry. That's outdoor positioning.
Yeah. You make it look so easy. ClearPath Robotics, it's a piece of cake.
Yep. Open field. More fun. Is there anything else you guys want to talk about or go over?
Well, sometime this week, I decided I was going to get my ROS command velocity messages to drive my vehicle, and I decided that right now, coming from the remote control, I just take the joystick and scale it and feed it to a PWM value. And that gives me nice, stable control over the thing for driving it around. I went back and tried to get the closed loop velocity control to work, and I just cannot make that work. And I wasn't sure if it was because I don't have enough resolution on the encoders, or I'm not sampling fast enough, or it's because right now it's up on blocks, so the wheels kind of bounce back and forth. There's no load on them, so it as they bounce forward, and then that reflects back to the motor. And I'm not sure if that's what my problem was. And then I thought, well, I'll switch over to my position control that I used to use on everything else. So you can either do velocity control, where you read the encoder and say, what's the current speed, and compare that to the requested speed. Or in position mode, you say, I am at this location, and in order to get it to move, you start moving the target position at a constant rate, and that's what gives you velocity. And I played around with that and decided that anytime I played with the software, it was just violently banging around. I thought it was going to destroy something. So today I tore the whole thing apart and pulled the motor off the gearbox. The motor just laying there now loose. So I'm in a position where if I go back and start playing with the software, I can see what it's doing without the risk of destroying anything. So that's kind of the point where I'm at right now, trying to figure out to get one or the other to give me closed loop velocity control out of the thing.
So you're matching it to like ticks per second?
Yeah, so
Or is
basically I would take in a velocity in meters per second, and I scale that to ticks per servo loop, and I'm running 10 loops per second right now. So it comes out to a tenth of a meter per second is scaling to be 451 counts per tenth of a second that I'm supposed to be getting. And then you just compare that to what's coming off the motor to what you're requesting, and then adjust the power of the motor accordingly. And for some reason, I can't make anything work right now. So I was basically confused, and I got to the point where the motor's out, so I can't destroy anything. So now I can go back and start playing with it and see if I can make the thing work. And actually, I've had like 3 different versions of this positional control software. It started off, I bought these things called PIC servo chips. So you just buy this this chipset from I'm going to call it a commercial thing. The guy might have been making them in his basement, but basically it was a microchip PIC processor that had this code in it, and they just worked great. You know, hook it up, and any motor I put it on would give me a decent control over the thing. And at one point I tried to rewrite it to put on a 68332 processor, which is a Motorola. It's like the automotive version of a Motorola processor. And I put it on there. I couldn't quite get it to work. And then when Atmel came out with their X Mega series that had 3 channels of hardware quadrature decode built into it, I wrote the code for that. I took the guy's spec sheet, and I had a microchip spec sheet saying, here's an app note saying, here's how you can make this work. And I basically just went down the line and made all the different functions work exactly the same way. And I got it working great on a X Mega chip. And then I switched over to a TI eval board, which had 2 channels of quadrature decode built in. And I switched the code over, made it run on that, and that worked really great. And now I've switched over to the ST Micro eval board. So as I keep switching processors, I have to start over again and try to figure out how to get this stuff to work. So now I'm at the point where the regular PWM, I send it out the motor, the thing just drives great. When I try to do my closed loop control, it all falls apart on me. So now I got to figure out why that's doing that, and just basically start from scratch and make it all work. So that's kind of where I'm at right now.
That's pretty good. You tore it apart and you got everything set up. So it's a big step.
Now, I kept talking about it's nice to make this robot small enough that you just pick it up and throw it in your car, but as it gets smaller and smaller, it gets real hard to work on this stuff. So I was, let's see, what did I do? Oh, somewhere along the line, I broke my flexible coupling between my encoder and my motor. I think what happened there was I made this bracket, and I put the thing on, and I thought, well, I'll stretch the thing out. That'll make it more flexible or whatever. And shortly after that, it broke. So it was like an aluminum piece that had a spiral cut in the thing. And apparently just as it was turning, that stressed it enough because I had stretched it out that it broke. And then I thought, so when I started playing this time, I thought, well, I'll run the thing, and it wasn't doing what I expected. I thought, well, maybe it's because that's broken. So I actually laid on the floor and got up underneath there and took the old one off and put the new one on. And it seems to be working right now, but that didn't solve all my problems. So then today I had to take the top off and take some other stuff out so I could see the motor. Then I had to take 3 bolts out and I could pull the motor off the gearbox and just lay it there. So that's the position I'm at right now. So now if I go and I've got access to it, I just got to go write the code. So I can write the code, then dump it out in Excel and say, what's the acceleration curve look like and all this kind of stuff. And right now it's just not doing anything reasonable. So but it's back to the point where I know where I've got, and it's just a matter of getting the code right to make the thing go. So that's where I'm currently at.
It's progress, promising.
I had the option, I could have done like I'm doing on the remote control and just take the incoming velocity and scale that to a PWM value. So on flat ground, I scale it and it'll go just the right speed. But as soon as you drive off the grass, and the thing's going to slow down because there's no closed loop control. So I got to get the closed loop control put back in there. So as you go into the grass, and it knows it's slowed down, it increases the power and makes everything work. And I thought I had this all figured out, and right now I realize I'm baffled at the moment. So it's a matter of just doing a lot of experimentation, I think, to see where I'm going wrong and try to get that fixed.
So I remember, I think last week or the week before, you were talking about the actual angle of your, if you convert that rotational velocity into an angle, and there is a little script, that will convert your rotational velocity into an angle, but I think it just does it does 60 to minus 60 or something. And I didn't know what, I never measured the angle on this lawn tractor. I basically just mapped whatever the full lock was left and right to that full plus or minus 60 degrees, or if it's 60 degrees total or something, whatever that was. But I don't know how much error. Will I be causing more error in the system because I don't know the exact angle I'm controlling to?
Yeah, and I haven't gotten back to that yet, but I'm thinking that's what I need to do is, eventually I need to figure out what that angle is. Because if Ross says turn at 10 degrees, I need to figure out what that 10 degrees is and what that does to my vehicle. So that's kind of on the back burner right now because I'm trying to get my speed to work right now.
Yeah, I think I need to calibrate my speed. I'm not holding correct speed, and I think Al's getting close. You'll be both of those, working on speed and then finishing up the base controller.
Until he runs into his house and screws up his steering, like some people have done.
Yeah.
So that's.
I think my target is the neighbor's trampoline. That's my target.
Back to Matt's question about how do you calibrate that automatically? Have you put any limit switches on your vehicle? So on the steering, so full left and full right would activate some kind of a switch, because that might be a good way to calibrate. You say, turn it all the way to the left until the switch comes on, and that's one number. Turn it all the way to the right till the air switch comes on. That's the other number you want. So that might be worth adding, say, micro switches to your setup somewhere to be able to measure that.
But how do you know center?
Well, center, then once you figure out the left and the right, then you go out and you start driving forward and watch some heading information.
Okay.
Say take your GPS heading, and if it's going off to the left, then decrement a few times until it's going straight, or if it's going off the right, increment a few times so it's going straight. And I think that's probably the best way to set your center. So you get it approximately. If you just take half of your left to right and say that's the center, and then start driving forward, and if your heading is varying one way or the other, you're not going straight, and then you increment or decrement that number till it says it's going straight, and then lock that down and say that's your center point. I think is the way that should be done.
Okay.
The other option with the Citron motor controllers, because you can control the power to the motor, you can give very little power to the motor and watch your potentiometer when it stops moving. And I mean, that's all the way to the left or right. The other thing I thought about is putting in, monitoring the amps the steering motor was drawing. And, you know, when it went to lock, it would be, I mean, if you were in a controlled situation, it would be drawing more amps when it was pegged left or right. Again, you don't want to break anything, so got to do that with some caution.
I finally put a potentiometer to measure the steering angle, so I always know what my steering angle is. I used limit switches for a while and did the find the middle, you know, go all the way left, all the way right, and then find the middle. And that works too, but it was a little more, you know, I had to go all the way left and all the way right. And then I really didn't know where I was in between exactly. So putting a potentiometer on there gives me a pretty exact position at all times.
And which one did you use, Alan, by chance?
It was, I used a fidget. I can put it in the chat here.
Is it a single turn deal or a multi-turn deal?
It'll only measure up to 360 degrees, and then it starts over again. So I put this up on the up and down part of the, you know, I don't know what it's called, but this isn't to measure the odometry reading. This is to measure the steering angle.
That's pretty nice that that potentiometer rolls over.
I'm not seeing it in the chat if you put it there.
Yeah, give me a second.
By the way, Matt, that gamepad I ordered, it shows it's a very precise delivery date. April 5th to May 1st.
Mercy.
So I think we know where that's coming from.
Well,
Yeah, that looks industrial.
yeah. And you can just keep turning this thing, and the only thing that happens is it turns over.
Right, that one switches back to 0 when it goes over 360. Yeah, I wouldn't. The word industrial is probably a little bit overrated there.
Shiny, bright and shiny.
And this one will continue to measure. This one doesn't flip over to 0. This one keeps going.
Pretty nice. Well, it's good. Looks like we're a little bit past the hour. Is there anything else? You ready for your week? A productive robot week.
Yes.
Yes. We're gonna make some progress. Alan's gonna get Ross installed next week.
One bolt or screw every day. That's my motto. Just one little step.
Awesome.
Forward progress.
It's great seeing you guys tonight. Hope you guys have a great week.
All right, you too.
Yeah,
Thank
Matt.
Talk to you later.
Okay, see ya.
Bye.